Okay, please, can you see my screen?
Yes, we can see
Yes,
your
Okay.
sir.
screen.
Yeah, good morning, everybody. So my name is David Ajayi. So we start from the foundations today, and next week we will build on the foundations. Okay, so R is the gold standard software package when it comes to statistical analysis, statistical modeling. There are other software packages like Python, like SPSX, like Stata, like SAS. Several software packages for data analysis, data modeling, and machine learning. But I prefer, a lot of people prefer R to these other software packages. Why? There are many reasons. There are several reasons why R is preferred to other software packages for statistical analysis, data modeling, statistical modeling, and machine learning. And these reasons include, you know, is a has a purpose-built software for data analysis. So it was developed by statisticians, and it has unmatched statistical capabilities. It has many packages for statistical analysis, more than Python, even more than SAS and Stata. It has superior data visualization. As a matter of fact, the gold standard for data visualization is ddplot2. It has massive package ecosystem. The comprehensive R archive network houses more than 27,000 packages. You can see that the ecosystem is massive. It's also great for reproducible research. Here you can use our Markdown or Portal. And lastly, it is free and open source. SAS is not free. MATLAB is not free. You have to pay for it. Even Stata is not free. So R is free and it's open source. Now let's look at working with House Studio. House Studio is an integrated development environment IDE for R. You can code in R console, but it is kind of difficult to say. It's not as easy as coding in App Studio. So now App Studio is an integrated development environment for R, and if you look at the structure of App Studio, so this is do I have highlights? Okay, pointer option. Let me use this. So this is the source. So we can write your code here. So this is the console. So this is the environment, history, and so on and so forth. And here we have 5 plots, and packages, and so on and so forth. Can use R as a calculator. Let me bring up my House Studio. You can use it as a calculator. I wish you together, please. Hello?
Yes, yeah.
Okay, good.
Yes, sir.
All right, thank you very much. I want to share on my screen. I'm not used to Zoom. Okay. So this is App Studio. This is App Studio. This is you can write your code here. For example, library. Okay, you're still coming to this tidy verse. So this is the source. Here you can write your code. This is the console. This is the console, the output of your code. If you run the code, the output shows on the console, and the environment, all the variables, the variables will appear here. And when we get to plots, this window will show your plots, the packages you've installed, and so on and so forth. So we can use that as a calculator. So here you can do the board mass addition. Let's say you want to add 10 and 2. How do you run? Just place your cursor here, and there's a run command here. You can see, or the shortcut is Control Enter. It's going to run your code. Do you understand now? For run, so this is a sign. Let's run that. Multiplication sign is the star. 10 times 2. Let's run that. Division sign. That's division. And you want to raise the power. The raised power sign in R is this, is the current. So 10 to the power of 2, for example, you can see. So you can use R as a calculator. Okay. So let me bring out the Mr. Toby, please, how do I share all my windows?
Yeah, so once you click on the share button, you
Okay.
see the one with screen.
The screen, okay.
Yes, yes. So once you select screen, you are
Oh,
sharing all. Yeah,
good.
yeah.
Okay, thank you very much for that.
Welcome, sir.
Once you, okay. So how do I go to my PowerPoint?
Okay, so just minimize the R.
Okay, minimize. Okay, all right. Thank you.
Welcome, sir.
Okay, R as a calculator. Now, assignment as an assignment operator. No, in programming, in any programming language, there must be an assignment operator. So you have your variable. So this, for example, this is the variable name, my name. No, in programming, a variable is like a container that holds information, that holds data. And where is this container located? It's located in the computer memory. So my name is a variable, and it's holding this information, John Doe. You see, and there are two assignment operators in. Okay, it's more than two, but at this stage, there are two. We have the arrow assignment operator, and this arrow. This is the arrow operator, and second operator is the equal sign operator. you are familiar with Python, know that the Python uses the equal as well as the assignment operator. If you ask me, the arrow operator is what is preferred to the equal operator, but whichever one, you are good to go. But I'll be using the arrow operator. Now, R is case sensitive. This name with the first letter, the first with the capital N, is not the same as a name with a small letter N. They are not what, they are not the same. So R is case sensitive. It's not like HTML, which is case insensitive. So just note that. Now, this is true for every programming language, every programming language. There are some reserved words, and R has many reserved words, including C. This C, we look at this small letter C when we are dealing with vectors. This C means concatenate, this or combined function in R. This key means to quit. This T, small letter T, is a transpose. If you are familiar with linear algebra, dealing with vectors and matrices, you can transpose a vector or a matrix. This T, capital T, represents true, capital F false. So these are Boolean values. These are true in, although it discourages using capital T as true and capital F for false. It discourages just write in full, true, false. If when we this is a conditional statement. It's a conditional statement, and else, if else, for looping, this is a vector, and so on and so forth. So if you want to look at some of the reserved words in the R, just you can just type this in the console, question mark reserved, question mark reserved. So our packages, want to extend our functionality, you need to install packages. There are some default packages. There are many default packages in R that's pre-installed. And this includes the stats, utils, and graphics for default statistical analysis functions, default graphic functions in R. So R has an extensive list of contributed packages, more than 27,000 packages, and to make use of all these functionalities, need to install packages, libraries in R. So how do we install packages? Make use of the library function. So let me go to R Studio. So now I'm in my R Studio. Now if I want to install packages, and also install, you can see .packages and put the package there. For example, I'm installing, let's say I want to install tidyverse, which I want to encourage everybody to install this. It has a lot of packages. For example, ggplot2, dplyr, and so on, and so many so many packages in this tidyverse ecosystem. We're making use of this group of libraries. Now you run this command. I have tidyverse installed. It's already installed. You can just install it. So it's going to take some minutes, like 5 to 10 minutes, depending on your internet strength. So after installation, you load the library using the library function. Put together, just tidyverse. Just run that, control enter, it's going to run it. You can see that it has a lot of packages. You have the plyr, you have the forecasts, you have ggplot2, you have the dates, and so on and so forth. Readout, stringout, typo, and tidyr. That's a lot. So we'll be making use of this ecosystem next week. Okay, that's how to install and load packages. Oh, the next thing is comments. How do we comment codes in R? So the comment symbol is the arch symbol. Arch symbol is the comment symbol, and anything to the right of the arch is what is ignored. For example, it's good to comment your code for readability. It's good to comment your code. For example, I'm in App Studio now. So let's say this is my name. So the shortcut for this is Shift Control C. Shift Control C. Shift Control C. If you don't like shortcuts, you can come to code. Code and let's locate comment code. You can see comments on comment lines. So let's say my full name. So I'm going to, the very name is my name. Though you are familiar with HTML, you know that John Doe is a popular name. So let's run that. Now we're going to print. Now I've assigned John Doe to my name. So my name is a variable, and it's a container for John Doe. So to print, you can use the print function. Or you can do auto printing. So what do I mean by auto printing? Just type name of the variable. Okay, I'm going to show the two. So my name, let me run that. Print. To print now. You can just do auto printing without using the print function by like this. So how is going to print that? That's auto printing. So mostly I use auto printing because it's shorter. Another comment, let's say, okay, remember the Pythagoras theorem. Don't worry, I have a mathematical and statistical background. So let's say I put something else. Please know that I'm not using small c. No, C is a function in R. It's a reserved word. That's why I'm using capital C to represent my hypotenuse. And that square root function, the square root function in R, squared plus b squared. Use the caret function for what was it called? For raised to power in R. So I can comment this. This inline comment. So just to annotate, this is Pythagoras theorem. You can do inline comment. So if you run this, it's going to give you error. Why? Because you have not defined what is variable A. Let's say variable A is 5. B is let's call that 3. So A is 5 and B is 3. So let's run that. So our C will be what? So let's print C now. What's going to be our C? Our C will be 5.8309, never like that. Good. That's how to comment in the what's it called? In R. Okay. Data structures. Data structures. So before you can master any programming language, any programming language, you have to be familiar with data structures. This is very, very important. Data structures in R, we have vectors, we have matrices, we have arrays in general. Matrices are, there are 2D arrays, we have factors, we have lists, and we have data frames. Now let's look at vector is the building block. It's the most basic data structure in R. It's the building block. Like remember biology, cells are the building blocks of what? Of life. So vector is the building block of the data structures in R. Here we have 5 types, basic types, which are very important. I want you to know them. We have integer, we have double, we have complex, we have logical, we have character. They are all very important. Now let's look at integer. Integers are whole numbers. No decimal, no. In computer programming, decimals are they are floating point numbers. So integers are whole numbers, no decimals, no nothing. So if you want to, in R, by default, if you type any number, it's going to be double, real number, because that's the default. That's the default. So if you want to write integers in the R, you have to append L. So X is an integer, and X is what? X is 7. So you have to append L. Integers in R. So let's say X is 7. One has to append L. If I don't append L, it's going to be a double. So integer, I'm going to append L. So I'm going to print that. When I'm print enter, control enter, so you can see integer. So the next one is the real numbers. So that's the default in now. It's default. So I'm going to call that y. Y is 3.142. That's a 142. That is pi. So let's run that. Control enter. Are we together? Let's print that. Control enter. That's 3.142. So the next is the complex. Complex is we have real numbers, we have complex number. If you want to go into scientific computing, you might, okay, let me just use might, or you will need to be familiar with complex numbers. So Ordinary, if you are doing the statistical analysis, statistical modeling, you might not need complex. If you're into scientific computing, you have background in physics, background in chemistry, and maybe in biology, bioinformatics, a bit of that, make use of complex numbers. So no complex number, a complex number has two parts. You have the real part and the imaginary part. So in R, the imaginary, so you have to append I. This I means imaginary. So after writing the number, you have to append I to it. So that I will recognize that it is an imaginary part. So in Python uses J, not I. So I will use I. So for instance, let's say we want to, Z is a complex number, complex, Z is equal to 5, and then use 6 plus 3, okay, let me use 4i. So this is complex number in R. So let's run that, Control Enter, that's the shortcut. So you can now come here and run here. I'm used to Control Enter the shortcut. Okay. So the next is the logical. This is important. You're dealing on the loop and what's it called? You're looping and you're the if. And making decision, make use of the logicals. So there are two values, true of true, false, true and false. Values. Example, let's say is adults. True is vector. We have not run it. Okay, yeah. So this is, can see, true. Next is the character text. This is character. People have been looking at this, my name. Let's say my friend. Let me use friend now. Convention I'm using for variable naming is the camel casing. This is the camel casing. You can use the snake case. In Python, snake case is popular. I'm used to, when I'm coding in Python, I use the snake case. In R, sometimes, most of the time, I use the camel case like this. Okay, good. So my friend, let me call this is Smith Jones. This is a character vector. Auto printing, say Smith Jones. Okay, so you have dealt with the 5 integer, double, complex, logical character. Now, multi-value vectors. So we have been looking at single-value vectors. So we have multi-value vectors. So vectors containing more than one element. For example, look at student names. This vector has, this is a character vector, and it has how many elements? It has 3 elements. So let me copy this to R. Okay, when you are copying codes from PDF, from Word, or from PowerPoint, you have to be careful. You have to be careful because of the, what's it called? The quotation mark. Because of the quotation mark. You can see if I run this, it's going to run perfectly. But if this is not highlighted in green, if this text are not in green, if you run this code, I was going to yell at you that it doesn't understand your quotation mark. So just take note of that. So most of the time, if you are copying codes, especially if the codes involve text characters, it's better to write in, copy it to R. So I'm going to change, I'm going to include quotation mark now. You can use the single or double quotation mark, whichever one. You can use the single, you can use the double, but I prefer double quotation mark, I prefer double, because if you can code in C++, you for characters use the double quotation mark. So here, let me run this. Jane, John, James. So this is a multi-valued vector. This is a multi-valued. To check the length, use the number of elements in this vector. Students' names. Let's run that and to enter. You can see the length is 3, so it has 3 elements. So the next is student course. This is a read vector. This is a read vector. It's the elements are real numbers. Let's run that to see. So length is also, if you invoke the length function, we call the length function, you're going to get 3 because it has 3 elements. Okay, good. We are making progress. Any questions? Are we all good? Are we all good? So I want to assume that. So the matrices. So matrices are 2-dimensional arrays. The elements should be of the same data type. So this is a matrix. This is a 2x2 matrix. So let me copy this to R Studio. Matrices. Now, I want you to pay attention here. The function is this matrix function. Now, you can don't need to cram everything. Don't need to. There is help in R. And the shortcut is, can use the F function. Are we together? F function, and type what we want to look up. So this is the window. It's going to, you can see matrix creates a matrix of the given set of values, so on and so forth. Now, if you look at this function, it has a number of parameters: data parameter, number of rows parameter, number of columns by row, and d name. This d name is dimension name. So now the starting point is vector. The vector is a building block of data structures in R. So this is vector. Vector. Now I'm using a colon operator. This is a colon operator, and if you are dealing with consecutive numbers, you can use the colon operator. Now, another way of writing this, which is a long way, is to do like this. A is 1, 2, 3, 4, 5, 6. So this is a long way. So we are dealing with consecutive numbers. 1, 2, 3, 4, 5, 6. So you can use the colon operator. Another thing is this. Let's say B is from 5 to 10. I just do 5 colon 10. Shortcut. Now, if you want to, you can. I'm using a column. This column, right? No, sorry. This semicolon, right? Semicolon. Because I'm writing more than one syntax, more than one command on a line. This is a line, so you can write multiple commands in a line. So to do that, you have to use the semicolon operator. Semicolon. So another statement is, this is a statement, B, you assign 5 to 10 to B, and I want to print. So I do semicolon. So this is what I want to print. So you can do that in a line. You can see B is equal to 5, 6, 7, 8, 9, 10. Okay, good. So now our data is a vector, which is A. And you are familiar with linear algebra. Familiar with linear algebra, you know, this is a 2 by 3 matrix. So these 2 represents the number of rows, and 3 represents the number of columns. 2 by 3. So row first. So the number of row is 2. You only need to specify the number of row or the number of column. So once one of these 2 is specified, there's no need of specifying both number of row and number of columns, because they are complementary. So the number of row, 2 rows, and by default, the filling is by what? Is by columns. I'll fill by columns, but if you don't like that, you can change. Sorry, by default, you can see by row is false. So R is going to fill the matrix by what? By column. So let me do both so as to show you the difference. So this is default, right? I'm going to call that A1. That's matrix A1. I'm going to do another one, which is A2. But here, I'm, I'm going to feed by row. I'm going to change this argument to true. So let's plot the difference. So statements in a line. Semicolon, don't forget the semicolon. If you want to write multiple statements in a line. Okay, this is A1, this is A2. What difference now? Let's spot the difference. You can see that A1 is filled by what? By column. 1, 2, that's the first column. The second column is 3, 4, and the third column is 5, 6. However, in A2, this matrix is filled by row. 1, 2, 3, row 1, row 2, 4, 5, 6. Good. Now, there are some functions associated with matrices. For example, the dim, this dimension. I want to change that to A1, A1, A1. So dimension, so 2 by 3. N row is number of rows. That's 2 rows. N column, number of columns, which is 3. That is matrices. So these are just these are brief overviews of these data structures. So it's something we can if you want to go in depth, we can spend like 2 hours on each of these data structures. So next is factors. Very important in data science. Very, very important. I want you to pay attention. So when you are handling categorical variables, categorical data, make use of factors. In R, it is called factors. So you make use of factors. So now there are 2 categories of categorical variables, 2 types. We have the nominal and we have the ordinal. So the nominal, no order of categories. In ordinal, there are what? There are logical orders. Logical orders. Now, how do we create factors in R? How do we create factors in R? We use the factor function. Factor function is the factor function. So let's start with the nominal factor. So I'm going to copy this because of our time. Okay, so now look at the first one, married. Is a factor, is a categorical variable, and it has 2 levels, no and yes. No and yes. So now, there's another name for nominal variable having 2 categories, and that name is what? It's binary variable. Binary variable. Binary variable. Binary variables. Binary variables. Okay. Now, so the starting point is also a vector. This is a vector. That's why vector is very, very important. Starting point is a vector. Now we are calling factor. We are calling this function using a vector as an input. The input is what? Is a vector. Now let's run that. Control enter. Control enter. You can see there are two levels, two categories. No and what and yes. I want you to know this. I want you to know this. App decides which level comes first using alphabetical arrangement, alphabetical order. No, in the alphabet, N comes before Y. N comes before Y. So that's why no is the first word, is the first category, and yes is second category. Now, what if I want a particular arrangement? I want a particular arrangement, for example, when you are dealing with level of education, that's education. And let me wrap that in factor. With level of education, I want none, you can no education at all, no formal education. Let's say this has tertiary, secondary, primary, why for primary? So we have all the four levels captured. Okay, let me add none, add primary again. Let me call this Edu1. Are we still together, please? Okay, so let's print this. Let's run this. Something. Enter. Control enter. No, we are fortunate here because this is the normal order, right? Non-primary, secondary, tertiary. And fortunately, it's also according to the alphabetical order. Non-primary, secondary, tertiary. So N comes before P, P comes before X, and S comes before T. Look at this city. Let's say this is also a categorical variable. Lagos, Port Harcourt, Abuja, Lagos, Abuja. Now, let's run this. Abuja, ALP, alphabetically. Now, let's assume that we don't want this arrangement. We want our own arrangement. We want Abuja first, being the capital territory, FCT, or we can even according to the population in ascending order. Abuja is out of this three. Abuja is the least populated, followed by Port Harcourt and followed by Lagos. Let's say that's the order we want. That's the arrangement we want. So we are going to use another parameter called levels. And these levels, the input or the argument is a a character vector. A character vector specifying the arrangement we want. We want Abuja first, followed by Port Harcourt, and followed by what? By Lagos. So let's run that. Let's run that. Control Enter. We now have the levels are specified. Abuja first, Abuja. Look at the levels. So I'm talking about levels. So the first data value, data point is lag. Don't mistake that with the levels. So the levels, we have Abuja, IBJ, we have Port Harcourt, and we have Lagos are specified. Now the next is the ordinal factor. Here there's a logical order. There's a logical order. Example, we are dealing with sizes, small size, medium size, large, and extra large. Extra large. So the difference here is that there's another parameter we have to make use of, which is ordered. It sets the argument to true. Ordered, set it to true. So let's run this. Now I want you to note the levels. You can see that this is a less than sign. SM is less than MD, MD is less than LG, that's a large, and large is less than extra large. Okay. So the next is a list. This is the most general class of data container in R. If you want to develop package in that's advanced package development in R, you must be able to manipulate lists. List is very, very important. Like vectors, list group data in a one-dimensional set. You look at that. Like vector, you can store all kinds of objects. This can be of any length. Element of this can be named or not. So I prefer. Any problem, please?
Sorry, please continue. Just continue. I think it's just a background noise. So I'll mute that background. Please, if you want to, if we have any question, please let's kindly use the chat button. Thank you.
Okay, thank you very much, sir. Okay, list. So to construct list in R, use a list function. List function. Now, this list is a named list. Named list. Okay, I'm going to show you the difference between named and unnamed list. Copy this to RStudio. So this is named. Okay, let's start with unnamed. Unnamed. So this is named list. Okay. So unnamed. copy this. Okay. What makes it unnamed? I'm going to remove name. I'm going to remove gender. Remove CGPA. This is an unnamed list. You can see that is it's not informative. Not informative enough. That is a function name in okay, let me use LST. Okay. So let's run this. Enter, control enter. You can see unnamed, no name. So no variable name for no field name. Let me use that word. There's something called field name. When we get to data frame, you see field name. Field name. So no field name. You can see it's not informative. It's not informative enough. Now named list. Named list. Now I want you to know that each field is separated by what? By comma. You can see this is the first field, department, separated by comma, second field name, comma, third gender, and lastly CGPA. So each field is separated by what? By comma. So let's run this. Control enter. And let's print. You can see now department statistics, name, John Doe, there are 3 students, Mary J and Jack Smith, gender, male, female, male, and these are just CGPA. And lastly, on data structure, look at data frame. Data frame. As a data scientist, most of the time, you'll be using data frame. So data frames are two-dimensional form of a list. In fact, they are lists. Data frames are what? They are lists. They are a subset of lists. And the conventional data structure data analysis. A data frame is presented in a tabular format. Tabular format. Look at that, we see that. And to create, use the word data frame function. Data frame, the function takes vectors as inputs, and all vectors should have the same length. We look at this. It's a very common mistake for beginners when you're creating a data frame. So we look at this. So how do we create a data frame? This data frame function, data.frame function. So the first field is name. Now the first column. The second column is gender, and the third column is what? CGPA. No, it's similar to list, named list. Let's copy this. Let's copy this. Frame. Okay. So this is a vector This is a vector, and this is also what? This is also a vector. So vector are key in R. So now I'm going to run this. So enter, Control enter. See tabular form. The first column is name, the second column is gender, the third column is CGPA. You can see that we have 3 columns and 3 rows. 3 columns and 3 rows. Good. Now, let's assume that I want to show you something now. I'm going to call that DF2. Now, if the vectors are not of the same length, so here CGPA, I'm going to remove the last element there. I'll make it, I'll remove that. So we have the length is 2, others 3. I'm going to call this DF2. I'm going to call this DF2. So let's run that and let's see what's going to happen. You can see error. Why? Because the vectors are not of the same length. So I'm going to do something next. I is going to assume, is going to replicate, let me add departments, a field, statistics. Will this work? Let's try. Will it work? Let's see if it's going to work. Here, let's run this, Control enter. Oh, sorry, there's no comma. So I want to clear my console. Let's see if that will work. Yeah, it works. Why? Let's print it. Now, because 1 is assumed to be, the length of this is 1, right? This has a length. Okay, let me annotate. Where is the annotation? Okay, because department is a vector having a length of 1. Name is a vector having a length of how many? 3. Gender, length of 3, and CGPA length of 3. Now, R assumes that 1 is a multiple of what? Of 3. You can do 1 times 3. It's going to give us 3, right? So I replicates 1, this statistic 3 times. Replicate it 3 times. So assume that the column has the same entry all through entry. So it's going to work in some cases. And this is a typical example of that case. So we can use dimension function df3. Let's check the dimension. 3 rows, 4 columns. 3 rows, 4 columns. 4 columns. That's a D dimension function. Okay. So the next section is selecting values. So how do we select values from our data structures? How do we select values? These are important when you are manipulating your data manipulation. Data manipulation. It's an important equation in the data analysis. In fact, according to some experts, 90% of your time is spent on data manipulation. About 8% of your time. If you want to do data analysis now, you start with raw data. Data manipulation takes like 80% of the time. 8% of the time. Okay, so let's look at selecting values from vectors. How do we select values from vectors? Here, make use of brackets. Brackets in the programming. This is what is called brackets. See, square bracket. This, trying to get. Okay, so this is called brackets. Can you see? Brackets. Sorry, these are brackets, and these are parentheses. Parentheses. Here are parentheses in the so in English, the parenthesis is called brackets, but we are dealing with programming now. So when I say brackets, I'm referring to square brackets. Okay, so let's look at back to App Studio. Selecting values. So you have a vector, let me call it vec 1. Let's say I'm going to use the column operator. Let's say 2 to 3 column 7. Let's print that. Let's run and print. You can see this has how many elements? 1, 2, 3, 4. Let's use the length function to check the number of elements. This has 5 elements. Now, please pay attention here. If you are familiar with AI, you use AI. One of the headaches of AI is data manipulation. There's a study we are conducting on that can AI replace domain-specific software packages for data analysis. And when we looked at data manipulation, we discovered that AI are still the LLMs like ChatGPT, what's it called? There's another one, Cloud, what's it called? ChatGPT, Cloud, what else? Microsoft Copilot, Grok, and so on and so forth. What we discovered was staggering. They are still LLMs are still inadequate when it comes to data manipulation. Maybe next week the paper will be published in print first. Next week, and you see yourself. So that's why data manipulation is key. It's key. I think it's where the bulk of the work is. We are doing data analysis. So that's why knowing how to select cases, how to select values, how to select cases is key. Okay, so pay attention. Now, if you want to select the first value, you do vec1 bracket, inside the bracket we place 1 because we want to select the first value. So let's run that, Control Enter. The first value is 3. The first value is 3. Unlike Python, which starts from 0, the first index is 0. In Python, in C, all this C, C++ and stuff. How is different? The first index in R is 1, not 0. So please take note of that. If you are coming, if you have background in Python, in C++, C, so note that the first index in Python is 1. Okay, so that's the first element. So second element, let's say we want to select the second with 2 and so on and so forth. So the third element is 5. Now, let's say we want to select more than one values. No, if the values are consecutive, values use the column operator. You can use the column operator. I want to select the first 2 values. 1, column 2, 3, L. Use the column operator. The first 2 values, 3 and 4. Let's say I want to select the from second to the fourth value. Also column that shortcut. So let's say the values are not consecutive. Use the C function. That C means concatenate function. Let's say I want to select the first value, the third value. I want to select the fourth value also. So let's see that 4, 5, 3, 5, 6. So that's that for vectors. So the next one is the data frame. Data frame. So I'm going to be using this data frame. Let me copy it. Let me use this EF3. Now, here, most of the time we're working with data frame. Let's say I want to select one value, row I, J. column J. So let's say I want to select Mary J. You can see that Mary J is in row 2, column 2. Row 2, column 2, DF3. So the row index box, row 2, column 2. That's Mary J, right? Row 2, column 2. So let's see what that will give us. You can see it's Mary J. Let's do one more. The ICGPA is 4.7, and this is row 2, column 3, right? No, column 4. DF3, column 4. Let's see what that will give us. Good. Most of the time, when we're selecting one value, not. So we're selecting single row, multiple rows, single columns, multiple columns. So let's look at single row, single row first. Let's say we want to select this observation 3. Observation 3. That's for Jack Smith. How do we do it? DF3. Put the row index, which is row 3. Because we want all the information pertaining to Jack Smith. That's the observation 3. We leave the column index blank. The column index we want will be left blank, nothing. We only specify the row index, which is row 3. So let's run that. What do we have? Department statistics, name, Jack Smith, gender, male, CGPA 3.5. That's single row. Let's do multiple rows. Multiple rows. Okay, let's say we have 2 males, right? We have John Doe and Jack Smith. Let's say we're interested in male data. Male data. One data for John Doe and Jack Smith. So row 1 and row 3. So multiple rows, because the indices are not consecutive. So there's 2 in between 1 and 3. So we use this function 1,3. The row index. Column index, we leave it blank. So let's run that. So we have gender, male, our observations from John Doe and Jack Smith. Okay, so let's move to columns. Columns. Column. Now, DF3, let's say we're interested in the CGPA column. That is column 4, right? Column 4. Column 4, do DF3 brackets. We leave the row index blank. The column we're interested in is the 4th column, 1, 2, 3, 4. So we put 4 there. Let's run this. Okay, you can see that it's returning what? This is a vector. If you want the output to be, there's a parameter. We need to adjust the drop is equal to let's run that and let's see. You can see that it's giving us what? A data frame. You are selecting one column and you want the output to be a data frame. You have to use this function, drop is equal to false. By default, if you are selecting a column, it's going to give you a vector. That's by default. But if you want a data frame, you have to use this parameter and change the argument to false. Drop is equal to false. Columns, multiple columns. Multiple columns. Multiple columns. Okay. Let's say we want to select name, gender, and CGPA. 3 columns. Just do DF3 because they are consecutive. Leave the whole index blank. Just do 2 column 4. And let's see the outputs. We have name, gender, and CGPA. Now, if the indices are not consecutive, DF3, let's say we want to select columns 1 and no, let's say columns 2 and 4. 2 and 4. That's blank. Function 2 and 4. Name and CGPA. So the next, almost done with the slide. Okay. So $sign. This is popular in R. Dollar. It automatically returns a vector. And using $sign, you can only select a column. Only select a column. So let's invoke the names function on this frame. You see, we have how many columns? So these are column names. department, name, gender. Now, let's say you want to select EF3 dollar. It's going to list if you are working in Arc Studio. Once you put the dollar sign, you will list the fields, all the fields in your data frame, all the fields. So name is selected. You can see John Doe, Mary J, Jack Smith. Let's look at another one. DF3 dollar gender. Control enter. And see male, female, blah blah like that. Okay, we have 20 minutes left. You want to import data, you want to import data. Imports. Our supports. You can import data. You can import Excel, CSV, CXV. Import Excel. You can import SPSS. You can import Starter. So here the extension is .csv. Okay, this is .csv. Please help me here. That thing is XLX. Okay, I'm right. Extension is this is .sav. For starter is I remember that. It's
DTA.
DTA. Okay, DTA times. Even SAS, you can import SAS. Yeah. Most of the time, because SPSS is popular, is the number one, is the most widely used data analysis package software. SPSS. You can Google it. Is the most widely used. So to import CSV with this Excel, you will need with the Excel package. So you can let's do I have it? We can search a package here. If you want to search, if you have a package, just come to packages and search, read. Okay, I have it. I think it's part of the what's it called? It's part of the tidyverse packages. So just install tidyverse and load it. So next week, so for SPSS, you need this package, call it the Avin package. Avin, SPSS and Stata, you need the Avin package. You need the Avin package also for Stata. So we need to install this Avin package. Need to install. So we will demonstrate. Let me look for the data set. Look for the data set. Sorry, I should have directory. Okay, so I'm going to, okay, this is data. So I'm going to copy this. I have a lot of, I have many data sets in here. So I'm going to copy this to my desktop and show you how to set working directory. Because you need to set your working directory, copy this to desktop. Okay, so if you want to make it use of, since you have made no reference to external files, no reference at all. So I'm working purely in R using environments, all the variables and environment variables and so on and so forth. So if to make reference to other files, external files out of this global environment, so you need to set your working directory. This is very, very important. So if you don't set, so let's get our working directory, working directory, it's called get wd. Let's look at the working directory. So documents, working directory, and my data I want to import is on the desktop and is inside a data folder. So I'm going to set, if you are working in RStudio, it's very, very, very easy. Very easy. It's very easy. So I'm going to go to sections, go to working directory, go to choose directory. So because I want to be working, the folder is on my desktop, and there's a folder, right? So I'm going to open this. You can see it has set my working directory to this folder. Are we together? Are we together? So it's very easy. Go to section, go to set working directory, choose directory, and navigate to where your directory is. Just navigate. Do you understand now? Go there. Once you get there, just select the folder. That's it. So it's going to set that folder as your working directory. Now, the next is that you can use the file. Just come here. Are we together? You can use this file, the files. You can see these are all the documents in my working directory. You can see. So if you want to use code, just use dir command and enter. It's going to list all the files in your working directory. dir command, directory function. Now, let's say I want to import this CSV, which I want to import data1.csv. This is it, right? Don't forget I'm in my working directory. So I'm going to use import CSV, import I'll be using read.csv function. This is default. This is a default function in R. Don't need to load any package to use it. read.csv, and what you need is just the name of the file, the file name. So since you can type and you can copy, so let me type sheet, that's the quotation mark, data 1 dot csv. I want to assign that to a variable. Let me call it, I have df. Let me call it demo 1. Let's do that. Let's run that. Control Enter. So let's inspect our data. Let's look at the structure str demo 1. Let's look at the structure. Control Enter. You can see the data frame. How many observations? 300 observations. How many variables? 6 variables. And the list of variables: age, gender, education, weight, height, blah, blah, like that. So that's how. Now, there's another important function in how. Add function demo. By default, we will print the first 5 observations. Okay, the first 6 observations by default. You can see age, gender, education, weight, height, hypertension. Now, that's by default. If you want to extend that, let's say I want to print the first 10 observations. Okay, don't let me overwrite this. Let's say I want to print the first 10 observations. N is equal to 10. First 10. Let's see, you can see the first 10 observations. There's also a tail function. So this is going to print the last 6 observations by default. As you can see, last 6 observations by default. 1, 2, 3, 4, 5, 6. And if you want last any number, last 10, last any number. Let's say this is, let's say we want the last 7 observations. Lastly, how do we write to, you have a data frame, you want to save as CSV. How do we do that? Okay, I'm going to manipulate this demo data set. Let's do some manipulations and let's save it as a CSV. Let's use our data manipulation skills. It's going to be, I won't be using any package for data manipulation. I'm not going to use any function. So next thing we look at that, I want to use pure R. Okay, let's say we want to observations. I want to select using age. Please pay attention to this. This is pure R, no function. I want to do it the primitive way. Let me call it that, primitive way. Let's say we want to select observations using age, and we want, let me see, range $1 age. Let's look at the range. 18 is between 18 and 70. The minimum is 18, the maximum is 70. Let's say we want age, let's say below 50. Let me use one condition, age below 50, and we want to select, let's look at the fields. We want to drop hypertension, we want to drop height and weight. We only want age, gender, and education. On this 3, age and education. So what do we do? Number 1. Good. So the roll index just puts demo 1 primitive way, K less than what? 50. No, 50 will not be included because it's less than 50. If you want 50 to be included, we do less than or equal to. Let's make it less than 50. And what are we selecting? We want to select age, gender, and education. I'm not going to be, I'm using variable name. No, I can just do, because I need age, gender, and education, I can just do 1 column 3. You understand? I can do that, but I won't do that and use age, gender, lastly, education. Now I'm going to assign this to, let me call this demo 2. Demo 2, and I'm going to run that. Let's run that. Good. So let's look at the structure. Let's look at our new data frame. This has 176 observations and 3 variables as we want. Now, so we want to write this as CSV. We want to write this as CSV, so we use the function write .csv, that's the function. The first one is read. Now we are writing. So the first argument here is the data frame. That's demo 2. The second argument is the file name. So how do you want to name? What name do you want to give to the CSV file? What name? What name? What name? What name? Let's call that. Let's call that training. Our training day 1. The extension is CSV. Don't omit the extension CSV. It's very important. It has to be there because we are converting the data frame in how to CSV file. And lastly, there's a parameter I use when I'm converting data frame to CSV, which is row, not names. If I don't put this, if I don't set this to false, I'm going to like all these names. Okay, let me look at this. Add demo to. I don't. This column index, no, row index, index one of these indices is going to form a new column and put them under that column. I don't want that, so I'm going to set that to what? False. I want just give me my data. I want my data, don't give me index. So I'm going to run this, control enter. So let's call the directory function and locate directory function. So let me clear the console first. Can I see the broom stuff here? Okay. So let's call the directory dir function. Let's see. Let's locate. You can see this is our CSV. This is our CSV. So, ladies and gentlemen, so we're going to stop here for today. So we continue next week. Continue next week. So thank you very much for your attention. Thank you very much for listening.
Okay, thank you very much, Mr. David. I don't know, please can we just appreciate Dr. David at this point? Please let's appreciate him with our emojis. We want to raise the we want to use the clap of hand emoji. We can do that now. Thank you very much. Thank you very much. I really appreciate. And thank you for waiting till this very moment. You know, I know it's not really been easy, and even on a weekend like this. So, please, at this point, we'd like to take questions. I know this is more like the basic, right? It's just the foundation, and of course, is highly needed because if you don't know what the data frame is, you may not be able to, you may even find it hard to be able to clean your data and all of that, right? So that won't keep us all waiting. So, do you have any question? Do you have any question at this point? You can unmute if you do. Let me check the chat option, chat box if there are any. Okay. Okay, any question? All right. I can see Victor's, and please kindly go ahead and ask your question. Kindly unmute, please.
Okay. Thank you very much, and thank you, Dr. David, for this wonderful session. It was really, really interesting to learn one or two here. But I have a question about when you're calling, when you're working with factors. I noticed you were using the C when you're trying to maybe call a row that are not um arranged in numerical order. So I don't know if it's like a must to use that C there, or is there a way that you can just leave that out and it will still not give you an error code?
Okay, thank you very much for that question. Yeah, no factor, right? We are dealing with factors.
Yes, ma.
Okay. So let me share my screen again. Okay, so the input for is vector. Let's say I can I can simplify this. Let me do that. This stuff here, this vector here, so I'm going to cut it into x. I'm going to call this MAR, let's call it vector. And inside this, because the input, you just do this like this. The same output, control enter, control enter, control enter. So here we are doing it in 2 steps. So you need a vector as an input in this function, as an input for this function. So this C, it means that you are creating a multi-valued vector, a vector having more than one element. More than one element. So if it's a single value vector, you don't need the C. Just for example, it's a single value vector. Yes, single value. But if the elements are 2 or more, you need this C function. This means to combine. You are combining 2 or more elements together. C, concatenate or combine. Do you understand now? Have I
Yes,
answered
ma.
it?
It's clear.
Okay.
Thank you, ma.
You're welcome.
Okay, thank you very much for that. Do we have any question at this point? Any question at this point? Okay, so so I take the silence as no question. All right. Can we have just one or two persons to share maybe what they they took away from this session today? Um, if you can unmute, please go ahead. If you can't, you may just use the chat box. So this will be the last thing we'll be doing today, while we close. So we'll be giving back some minutes. We're supposed to close by 12:30, but looks like we quite finished early. So anything that stood out for you today?
Yeah, good afternoon.
Good afternoon, Mr.
Yeah,
Clement.
yes. So our instructor, thank you so much. Although I have a bit of background in art, but the way you simplify everything make it so worth it. And my time today has totally worth it. And I hopefully just pray that you make this recording available. I would love to use it to just still listen to it so I can brush through my coding skills. And I want to thank you again. Thank you so much. And you can be sure that you've imparted knowledge.
Oh, wow.
You're
That's
welcome.
impressive.
You're welcome. Thank you very much.
Thank you very much. Thank you very much. Do we have any other volunteer who would do that? Okay, I can see Mr. Victor's chats. Thank you very much for the lecture. Please, can we get the recorded version early so we can go over it? Yes, would share this as soon as possible, no later than today, no later than today, so you have time to, to explore. And I think Mr. David to be able to share with us some the code for this the R script for this session so that we'll be able to follow through and all of that. So but generally I can assure you that you will get the necessary support for this webinar. So want to appreciate you one more time for joining us today. and we look forward to hosting you again next week Saturday. And while we are waiting for the next the next webinar. So we are also planning another webinar session very soon. So, but this is going to focus on data analytics, where we'll talk about Power BI. We'll talk about tools like Power BI, how you can do some data cleaning in Power BI, how to visualize your data in Power BI. So we are not just focused on the data science part, right? So we're also looking at the data analytics part. So, but we'll continue to reach out to you via the email, and please do well to follow us on our social media platforms. We're on X, formerly Twitter. We are also on LinkedIn. We're also on Instagram. So our handle is at DUAC_consulting. I'm going to type that now. DUAC_consulting. So that is our social media handle. So across all the social media platforms, DUAC_consulting. So we look forward to hosting you again for our future webinars. And thank you very much. Do have a lovely weekend and a blessed afternoon. All right. Bye, everyone.
Bye.